In this video we're going to look at angle problems, in particular with relation to circles. Angle problems can usually come up in your National 5 exam. It could be a 3 or a 4 mark question potentially, and there's a lot of stuff that you need to be able to recall and apply. But if you can get these basic facts in place just now, you're going to be able to fit the pieces together successfully to answer the question correctly. The first thing that we're going to recall is the fact that in a circle, if we've got a diameter AB, so here's a diameter goes from one point in circumference through the centre to the other point in circumference. If that diameter joins another point on the circumference, so A joins this point in circumference, B joins this point in circumference, at the point that they both join on the circumference, it creates a right angle. That would also be true if we went this way, as long as it's going from the diameter and it's meeting at a point on the circumference. It will always work. For example, we could do another one here. B will come down and meet at A. Each time it creates a right angle. So how we state this theorem is angles in a semicircle equal 90 degrees. Angles in a semicircle equal 90 degrees. And we're going to use that property later on to help us answer some questions. Okay, the next property we're going to look at after looking at angles in a semicircle is a tangent. A tangent is a line which touches the circumference of a circle at only one point. For example, a tangent is a straight line and it's only touching at this point here. You could have at this point here as well. As long as it touches just at one point, then the line is a tangent. What is special about tangents and circles is where the tangent joins to the point on a radius, or on the radius here, or for example where the tangent joins to the radius here, where they intersect, where their point of contact is. Where that occurs, it creates a right angle. Where it occurs, it creates a right angle. Okay, and that would be the same on the other side as well. So when you have a tangent to a circle, where the tangent and the radius, like where they intersect, where they touch, where their point of contact is, that the angle that is created is 90 degrees. Okay, what we're going to do is we're just going to look at a few examples and just to see like how the questions can look and how we're going to apply our knowledge and pick up a few other angle facts on the way. Okay, so in the above diagram, O is the centre of the circle, PQ is the diameter, PQR is a straight line, RS is a tangent to the line at S, angle OPS is 28 degrees. Calculate the size of QRS. So we want to calculate this angle in here. So there's not like a tried and tested way to solve this. How I solve them is I just fill in all the information that I can and I just try and fill in all the possible angles and then I just see where I'm going to end up. Okay, so let's work through this methodically. Let's look at each fact in turn. PQ is a diameter of a circle. So let's look at the diameter. PQ. So PQ is meeting at the circumference on S. So P is meeting S and Q is meeting S. So that is angles in a semicircle. Angles in a semicircle create a right angle. So that's me using this fact. PQR is a straight line. Not sure if that's going to help me yet. RS is a tangent to the circle at S. So tangent to a circle creates a 90 degree angle where it crosses over. So once again I'm just going to... So this bit in here is also a right angle. Okay, so I've used my information here. What other information is the question given me? It's given me this angle of 28 degrees here. firstly, I'd like us to have a look at the triangle OPS. So that is this triangle here. Okay, a few things to note about this triangle. OP is a radius. OS is a radius. That means that these two angles, these two sides are the same length. So essentially what we've created for angle OPS, if this is the same as this, and if we're given that this is 28 degrees, we know that in an isosceles triangle, the base angles are the same. So if this is 28 degrees, it means that this also has to be 28 degrees. So I can fill in this angle in here to be 28 degrees. Okay, so still looking at this triangle here, I've now got two of my three angles. So I can find out this third angle because the angles in a triangle add up to 180. So if I add together 28 and 28, I would get 56. If I subtract 56 from 180, I would get 124 degrees. Okay, so like I say, I'm just filling in the pieces of the puzzle just now. I'm just filling in like as many angles as I can. Next angle that I'm going to look to fill in is this angle in here. I'm going to do that because this is a straight line. I'm now going to use PQR as a straight line. I'm now going to use this fact because angles in a straight line add up to 180. They sum to 180. So if this part here is 124, to make this whole line sum to 180, I'm going to need to do 180 take away 124. You would obviously be setting out your working as you'd be doing this. That would give you an angle of 56 degrees. Okay, so now let's look at this triangle here, OSQ. If we have a look at, I'll just do a wee sketch again of OSQ. OSQ. And I've got that this up here is 56 degrees. Once again, let's note that OS is the radius, OQ is the radius. That means that OS and OQ are the same length, which means that this angle here is going to be the same as this angle here. That's slightly different from the triangle OPS. Okay, so let's think about this. There's a couple of ways we can do this. How I'll show you to do it is, I'll show you to do it how to apply the rule of the isosceles triangle, but there is another way that I'll discuss as well. I know that the angles in a triangle add up to 180 degrees. I know that these two angles need to be the same. So what I'm going to do is I'm going to do 180. I'm going to subtract 56 because that would then tell me what the angles are that to be shared between these two. So then I'm then going to divide that by 2 because then that would give me each individual angle. 180 take away 56 is 124. 124 divided by 2 is 62 degrees. So this bit in here is 62 degrees. This bit in here is 62 degrees. So we can fill that in our picture. Also, this makes sense. This is like the other property that I was going to say that I was going to mention. If we think back to the start with how we created, like we drew in our right angles, we know that this part here is 28. If we know that this part here all the way around is 90, I could have found this angle by simply doing 90 take away 28. I then could have applied my knowledge of isosceles triangles to fill in that as 62 as well. Like I say, there are numerous approaches you can do to solve these angle problems. Okay, now let's look at the triangle QSR. QSR. I'm just filling in every possible angle that I know. I'm just going to fill it up here. QSR. Okay, so let's now apply this reasoning to this bottom triangle. I know that from here to here is 90 degrees. I know that from here to here is 62. So if from here to here is 62 and from here to here is 90, to find out this angle in here, I can do 90 take away 62, which will give me an angle of 28 degrees. Let's have a look at this angle in here. We've got a straight line. Angles in a straight line add up to 180. So to find out this angle in here, which would correspond to this angle here, I could do 180 take away 62. 180 take away 62 is 118 degrees. Okay, nearly there with this question. We want to find out this angle in here. The angles in a triangle add up to 180. So if I sum 118 and 28, 8 plus 8 is 16, carry the 1. 1 plus 2 is 3, plus 1 is 4. And 1. And so this is what the two angles add up to. So to find out what the remaining angle is, I'm going to need to subtract 146 away from 180. So 0 take away 6 I can't do. 10 take away 6 is 4. 7 take away 4 is 3. 1 take away 1 is 0. So this angle in here is 34 degrees. Notice how we've used a lot of different angle properties there. We've used a lot of them. That is the sort of thinking. I went through this quite in detail, but fill in every possible angle that you can. Okay, because by doing so, you're going to make sure that you're correct. You can check your answer by checking, like, let's say that every triangle adds up to 180, that if you've got an isosceles triangle, the base angles are the same, and so on. So calculate the size of angle QRS. QRS is 34 degrees. Thank you.